A very good morning to all of you. I cordially welcome you all for this applied thermodynamics course. So the today's classroom discussion topic is the problems on heat balance. So in the previous class, we discussed about how to draw the heat balance sheet for a given boiler. That is, what is the input and what are the output. So always we have to balance. The input will be equivalent to 100% and output will also be equivalent to 100%. So based on the previous class theory, now in the today's class, we have to solve some problems on the heat balance sheet. So the motivation for the today's class is it is very essential to know to draw the heat balance sheet of a boiler to assess the performance of a boiler. So the outcome of the today's lecture is after completion of the lecture, you should be in a position to solve the problems which are given on heat balance sheet of a boiler. So that's why just you recollect the previous class notes, which is important one, that is on the how to draw the heat balance sheet. Now go through this particular the problem. So the data is given. So first of all, write down the given data and is asking us to find out the four parameters. The first parameter is equivalent evaporation per kg of the fuel. And here the second bit is also equivalent evaporation, but the different units per square meter of the heating area. Third one is the thermal efficiency of the boiler, and the fourth one, that is the heat balance sheet. So that is, this particular problem is totally based upon the previous, the 3 to 4, the classroom discussion topics important notes. So that's why please go through the previous CDTs to understand this particular problem, because definitely the heat balance sheet, one problem will be given in the examination. So don't miss this particular one. So always you concentrate on the theoretical aspect. Now you apply whatever the theoretical aspects you learned in the heat balance sheet. Now you have to apply your knowledge to solve this particular problem. So now our first duty is to calculate equivalent evaporation per kg of the fuel. Now let us see how to solve this particular one. So I've already told you that first you write down so the given data. Next one is, so the formula to calculate the equivalent evaporation, because from the last 4 to 5 classes we are solving this equivalent evaporation, the formula you should remember. So that is MA into H minus HF by 2257. So how to calculate MA? That is important one. MA will be equivalent to mass of the steam divided by the mass of the fuel. So the mass of the steam he has given as 700 kgs per hour. So substitute here. So m dot A, so that is equivalent to m dot S by m dot F. So that is m dot S he has given as the 700. So then the mass of the fuel, that is the oil consumption, is given as the 55. So substitute here, you are able to get MA is equivalent to so and so. Now how to calculate H and HF? So I told you that HF is nothing but enthalpy of the feed water. So here he has given the pressure will be equivalent to, that is 10 bar pressure. So at a 10 bar pressure, what is the value of the HF and what is the value of the HFG? And similarly at a 60 degrees centigrade of the feed water, what is the HF1? HF1 is nothing but is a water. So it is equivalent to 251.11. So he has given that it is a wet steam. So the enthalpy of the wet steam can be calculated from H is equivalent to HF plus X into HFG. So H value is so and so. HF1 is 251. Now heat supplied to the steam in the boiler is equal to H minus HF1. So H minus HF1 you are able to get 2486. So substitute here. So MA value already we calculated 12.72. H minus HF is 2486 and 2257. So by doing so we are able to get equivalent evaporation is equivalent to 14 kgs of steam per kgs of the fuel. That is the first bit answer. So in the second bit also is asking the equivalent evaporation, but per square meter of heating area. So that is here MA is equivalent to 700 kgs per hour. So that is same the mass of the steam. But here the heating surface area is given as 21.4 square meters. So that's why here you have to substitute 21.4 square meters. It is not m dot F. So in the previous problem, we have taken MA is equivalent to m dot S by m dot F. But here the m dot F is replaced by, so this particular heating surface area. So that is equivalent to 21.4 square meters. So the formula will remain same always. M dot E is equivalent to M dot A into H minus HF by 2257. The only thing is that MA value will changes because the denominator value changes here. So MA is equivalent to 32.71. By substituting, so we are able to get it as is 38 kgs of steam per meter square of heating area per hour. So that is the second bit answer. Coming to the third bit, that is the thermal efficiency of the boiler. So you know that the thermal efficiency of the boiler is nothing but is the heat utilized in the boiler, that is QU, by heat supplied by the fuel, that is the QS. How to calculate heat utilized in the boiler, that is M dot S into H minus HF. So you know M dot S is equal to 700, H minus HF already we calculated as 2486. So by doing so, we are able to get QU. And heat supplied by the fuel formula is MF into CV, that is the mass flow rate of the fuel is 55 kgs per hour. Calorific value of the fuel is 44,000 kilojoules per kg. So QS value is so and so. By substituting in this particular formula, we are able to calculate boiler efficiency is equivalent to 71.93. So that is approximately equivalent to 72%. So the last one, that is the heat balance sheet. So to draw the heat balance sheet, first of all, we have to know how much amount of the heat is supplied by the fuel. So here we are taking, actually the formula is nothing but Qn is equivalent to Mf into Cv, but here we are taking Mf is equivalent to 1. So that's why the formula will become it is equivalent to calorific value. So that is equivalent to 44,000. So this is my input to the heat balance. Now the various other parameters are how to calculate heat absorbed by the water per kg of the fuel during its heating and evaporation. Q1, by substituting here, we are able to calculate 31,630 kilojoules per kg of the fuel. So next one, these are the various parameters which are involved in the heat balance sheet. So that is the third parameter involved in the heat balance sheet is the actual air required per kg of the fuel burned. So that is nothing but M dot G is equivalent to M dot A plus MC. So he has given that 0.85 kgs of carbon is also present per kg of the fuel. So thus the mass of the dry flue gases formed per kg of the fuel will be equivalent to M dot A, that is N into C by 33 into CO plus CO2. By doing so, we are able to calculate it as 17.1. So M dot G is equivalent to 17.95 because without M dot G, you cannot calculate the heat carried by the dry flue gases. So G stands for, subscript G stands for is the dry flue gases. So heat carried by the dry flue gases formula will be mg cpg into delta T. So Q2 can be calculated as 5944.8. The next one is, the next part of the heat balance is how to calculate heat carried by the moisture per kg of the fuel. So M dot V is equal to 9H, so 9 into 0.14, so it is equal to 1.26. At 0.08 bar, so we are able to calculate Hg is equal to 2577 kilojoules per kg, and saturation temperature is equal to 41.54 degrees centigrade from the steam tables. So heat carried by the moisture can be calculated by using this particular formula. So by substituting all these things, we are able to get Q3 is equal to 3931. And here the last bit is nothing but unaccounted losses, that is the heat lost by the radiation and convection. After that, we are able to have unaccounted losses. So Q4 will be equal to Q in minus Q1 minus Q2 minus Q3. So the heat lost by the radiation and convection and other unaccounted losses will be equal to 2494 kilojoules per kg of the fuel. Now by getting all these things, now we have to draw the heat balance sheet. So that is the tabular column. So here you are able to have what is the input, that is heat supplied by the fuel, that is equal to 44,000 kilojoules per kg. So that is the, by summing all these things also you are able to get 44,000. So then only the input will be equivalent to 100% and the output also will be equivalent to 100%. So far we have calculated Q1, Q2, Q3 and Q4. So Q4, and here you calculate, that is how much amount of the inlet energy is used to generate the steam. That is very good. It is 72% of the heat energy is used to generate the steam. Now these are all the losses due to the various sources, due to the dry flue gases and due to the steam and due to the unaccounted losses, the 5.7%. So by summing up all these things, so it should be equivalent to 100%. So that is called as the heat balance sheet of a boiler. So I hope the heat balance sheet of a boiler is clearly understood. So in the next class also, we will solve some problems on the heat balance only, because it's very important topic, so that with the next class we are able to complete this particular unit number 2, that is the performance of the boiler. Thank you very much for attending this lecture on heat balance sheet problems on a boiler. Thank you.